We got a fun one. Look, 4 terms in the numerator, 4 terms in the denominator. Your first best guess would be factoring by grouping. Doesn't always work, but it's worth a shot. So let's look at the first 2 terms. GCF is x squared. It's going to give us 2x plus 3. GCF here is 16, negative 16. Let's factor out a negative 16. Going to give us 2x plus 3. Oops, so far so good. You know it's going to take an extra step. Let's just go ahead and get there. That's going to be x squared minus 16. And then 2x plus 3. Oh, good grief. Let's keep factoring. X plus 4, x minus 4, 2x plus 3. Numerator is done. Took us a while to get there, but we're there. All right, GCF in the first 2 terms of the denominator is 4x squared. And that leaves us with x minus 4. And then the GCF of these 2 terms is negative 9. That's going to leave us with x minus 4 as well. So we're going to have x minus 4 right here, and then 2, whoops, I'm getting ahead of myself. 4, not 2. 4x squared minus 9. All right, 2x plus 3, 2x minus 3, and then x minus 4. Oh, do you see what's about to happen? Cancel, 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 cancel. One more step. The final reduced form is x plus 4 and 2x minus 3. Hopefully you tried that on your own, he said at the end. All right, x-intercept. Let's just go ahead and jump into that one. Nah, let's write these first. Switch colors first. Holes, truly more than one. Let's leave some room for that. Vertical asymptote and horizontal asymptote. All right, x-intercept is going to be where x plus 4 equals 0. So x equals negative 4. 1, 2, 3, 4. Y-intercept is 0 plus 4 over 2 times 0 minus 3. There we go. Negative 4/3. That's negative 1 1/3. So about right here. Holes, 2 of them. You canceled out at x minus 4. So if x minus 4 equals 0, please do this in your head. X equals 4, and that's going to give us 4 comma something. Okay. We also had where 2x plus 3 equals 0, and that is at negative 3/2. That is negative 1.5. We'll still call it negative 3/2. There we go. And we need to find the other coordinate for both of those, and that's going to happen when we plug things into this. So we're going to have 4 plus 4 over 2 times 4 minus 3. And so that gives us, let's see, 8 over 5. 8/5 is going to go there. And then this one is going to get a little tricky. Oh boy. Let's not use a calculator. Negative 3/2 plus 4 over 2 times negative 3/2. That's negative 3 minus 3. So negative 6 in that denominator. Numerator is going to be 1.5 taken away from 4 is going to be 2.5. So 2.5 over negative 6. Let's double the numerator, makes it a 5. Double the denominator, makes it a 12. So negative 5 over 12. All right, wow, what a mess. Let's see. 4, 1, 2, 3, 4, and then negative 8/5. That's a little more than 1. So 1.6, a lot more than 1. Yeah, 8/5 is, 1.6. So 1, 2, 3, 4, positive 1.6, 1.5, open circle there. And then negative 1.5. And then negative almost a half. About right there. Okay, whew, my goodness, what a mess. Now you may want to get a visual for it. Feel free to graph it if you like. I am not going to right now. So vertical asymptote on this one is 2x minus 3 equals 0. So x equals positive 3/2. That means that we have a vertical asymptote at 1.5. That's going to happen right here. And the horizontal asymptote is going to happen, and you can go all the way to the reduced form if you like. We can go to the very beginning. The degrees of the numerator and denominator are the same. So you end up with comparing, dividing. The leading coefficients, 2 over 4, is going to give you 1/2. So 1/2. My goodness, this one's fun. 2 holes in this one. Oh my word, I did that in the wrong color. Wrong color. I gotta start the whole video over. I'm kidding, I'm not. I'll make it work. All right, let's connect some dots here. Don't cross that blue-red line. Phew, that's a bumpy curve. There it goes. And then we're going to swing this one around this way. Let's not be too picky about the exact points, other than the ones that we found. All right, let's talk discontinuities here. I have some room. We'll write them up here. So we have 2 holes. So we have we have a removable. Let's turn this into an R. Removable. Removable discos, plural, at x equals 4 and -3/2. 4 and then -3/2. Both of those are x values. And we have a non-removable disco at x equals, right there, vertical asymptote, 1 1/2, so 3/2.